We need to make sure we have some things mastered, and you need it for this section. When you're ready, we'll get started. Oh, wait a minute. Okay, basic things that you should have mastered. What does the sine of theta equal? What do you know about the sine? I'm not talking about the graph, just in general, your basic information of sine. What do you know about it? It's y, and it's y in the unit circle. Otherwise, it's the opposite leg over the hypotenuse. So really, we want to talk about right triangles. And you need to have this part down. This is the basic part you learned from Algebra 1. The sine is the opposite leg over the hypotenuse. The cosine is the adjacent leg over the hypotenuse. And tangent is opposite leg over adjacent. So that's the basic thing that you came in here with. So sine is really y over r, the radius of whatever the circle is that we're looking at, or the hypotenuse of the right triangle, okay? And in most cases, the sine is y because we're dealing with the unit circle. Now, some of the problems today, we're not working on the unit circle. We're outside of that, so you would actually need to have what the hypotenuse is. All right, now what do you know about cosine? Or let me ask you this, is that all you know about sine? Is it related to anything else? Not yet? No? Not cosine. Cosecant. Okay. So what do you know about the cosecant? It's 1 over the sine, or r over y. Okay. And what you're telling me, these are all the same things. We're just manipulating what we use. Just like 12 feet is the same as, or excuse me, 12 inches is the same as 1 foot, right? It's the same thing. We're just writing it in a different way. And that's really what today's lesson, section 3, is all about. Rearranging and manipulating the expressions that you've been given, but you've not dealt with that in trigonometry yet. But it's the exact same concept, right? Okay, just make sure. Cosine, what do you know about cosine? Give me the simple part of cosine. X over r, and it's just x in the unit circle. What else do you know about cosine? Secant. Remember, cosecant does not go with cosine. That's how you can tell the two apart. I keep saying that, but you guys keep telling me the same thing every day. So, what do you know about secant?
R over x.
Okay. And the tangent. Theta. What do you know about the tangent?
X over y. Y over x.
Opposite would be the y. I mean, if you need to look at it, this is what we're talking about. If that was theta, that's y. This is x, and then your opposite, or your hypotenuse, okay? Whatever it is you're looking at. So, opposite leg is the y, or the adjacent leg is x. So y over x. And then the cotangent, x over y, or 1 over the tangent, and vice versa. The cotangent is the tangent is the same as 1 over the cotangent. So they are reciprocals of each other. That's important. So these 6 functions, you need to be able to tell me the values of these all 6 things, given any information I give you. Now that's what we've been working on in all of December, okay? So let's talk about something new. Fundamental identities, which is really what that is. But I'm going to give you some formulas to go with this. In a right triangle, how do you use the Pythagorean Theorem? What would you say? Pythagorean Theorem, what would you say with this? X squared plus y squared equals h squared, right? Now in a unit circle, h is 1, and you have x squared plus y squared equals 1 squared, right? In a unit circle, the r is 1. And in a unit circle, you told me that the sign is y. And you told me x was cosine, right? So really what you're saying is cosine squared plus sine squared equals 1. That's a neat little formula to have available to us. Again, we're just using what we know to come up with some things. And the other thing we have is 1 plus the tangent squared of theta equals the secant squared of theta. That's one that you need for your for what we're going to do today. And then 1 plus the cotangent squared of theta equals the cosecant squared of theta. And you can rewrite these. You can say sine squared equals 1 minus the cosine squared. I mean, you can rearrange all of this stuff. There's an infinite number of ways to be able to do these things if we just keep on manipulating. Okay? Having said that, there's multiple paths to finding an answer. And meaning there's no necessarily one set of steps to get you there. But I'll try to guide you, okay? This is really what you're going to be using most often for what we're doing today. Yes, we want to know this, though, for the part that we're going to talk about. You need all of this to answer your homework problems. So, those are all things that should be on your cheat sheet that I'm not giving you yet, but you can add that as I give it to you. We'll talk about the area of the triangle here in a minute. So let's go ahead and take a look at some of the problems that are kind of difficult on 6-3. How about we just start with the first part of the assignment, 35 through 38. Is there any problems with that? Would anybody like to see one of those to begin with? Okay. Is there one that in particular you want to look at, or do you want me to just pick one? Alright, I'm going to pick the even ones to do, alright, because you don't have those answers, and that way you can kind of see how it's being done. You have the answers and the solutions of how to do the odds, so hopefully after you see it a few times, you'll be like, oh, now I understand what they're talking about. 36, the tangent of theta. The tangent has to be negative. Well, you told me the tangent is y over x. Well, for the tangent to be negative, that means y and x both can't be negative, because if y and x are both negative, it's positive, right? Alright, so in the quadrant, for tangent to be negative, either x is negative or y is negative. But they both can't be. So we're not talking about the third quadrant. And we're definitely not talking about the first quadrant, because everything's positive in the first quadrant. So we're talking about either the second quadrant or the fourth quadrant. Then they give you the second piece of information. The second piece of information is the sine of theta is negative. Sine of theta is negative. You told me that the sine of theta is y. So where is y negative out of these two quadrants? Fourth quadrant. Y is not negative here.
Yeah.
Okay.
Yeah.
So the answer here is the fourth quadrant. That's all it was asking. Find the quadrant in which theta lies from the information given. So that's how you do that. Let's do 38. 38, the cosecant. Cosecant is positive and the cosine is negative. Okay? Cosecant is what? Which is the same, basically, we just need to know positives and negatives, so y is going to be positive, right? So y is going to be positive. We know about the cosine. Cosine is the same as x, and that's just saying x is going to be negative. So where are we? Y is positive, and x is negative. Quadrant 2. All right, now we have those. Figuring it out. All right. The next 6 problems are probably the most difficult out of the whole assignment. Alright? After you see the other problems, you'll think, oh, these were the hardest ones. But when we're done, hopefully you won't think they were that difficult. Some of them are kind of hard to understand, while others are a little easier. So let's just do number 40, the cotangent of theta. 40. I want to change, this is what the instructions are saying is this. Change cotangent of theta so it is the sine of theta. And the information I need for positive or negative is in quadrant 2. We'll worry about the positive or negative at the end. I'm going to manipulate the cotangent of theta so it's the sine of theta. That's like me saying, I want to know what 12 inches is, but I want it in feet. And you're like, oh, well, that's 1 foot. That's the same type of thing as what we're saying here. We're going to convert, kind of. We're going to change cotangent so it is written as the sine of theta. In terms of the sine of theta, not just the sine of theta. Okay? So it could be sine squared, it could be 1 minus the sine squared, it could be something like that. But the only thing in the expression is going to be the sine function. It won't be any other trig function. That's what it's asking. That's what it's asking you to do. So, we start in one of 2 places. Either we're starting here, or we're going to use this information. Because both sides are true. One side's going to take you longer to get to the answer than the other one. So you're just going to have to try. There's only one way to do it. Once we start doing this, you should be able to think a couple steps ahead and say, oh, I think we should use this instead of this. Or vice versa, okay? Cotangent. I look up here and cotangent is the same thing as 1 over tangent. Do I need tangent? No. Stop before you do anything else and say, okay, let's try the other way. Over here, where do I have cotangent? I have cotangent right here. What else do I have in here? I have the cosecant. Do I need the cosecant? But do you know something about cosecant? What do you know about cosecant?
Cosecant is 1 over sine secant.
Oh, that's thinking 1 or 2 steps ahead. So now you say, we don't know yet. I've not done this in a couple months, so I'm not sure if this is right. But what we're going to do is we're going to go ahead and take this bottom equation and we're going to solve for the cotangent. That's what this is saying. Anytime, whatever's first here, that's what we're going to solve for if we're going to use this stuff. So let's write this down. 1 plus the cotangent squared of theta equals the cosecant squared of theta. But I don't need the cosecant squared. I need the sine squared. The sine. But we'll change that here in a minute. How do I get cotangent squared by itself? Now this is just, at this point, it's just algebra.
Subtract 1.
Subtract 1. Good. Cotangent squared of theta equals the cosecant squared of theta minus 1. Now, how do I get rid of the square? Yeah, say square root of both sides. So the cotangent of theta is the square root of the cosecant squared of theta minus 1. Excuse me. We good so far? Now, what's the cosecant? What's cosecant? What's another way of writing cosecant?
1 over sine.
1 over sine. So the cotangent of theta is the same thing as 1 over, cosecant squared is the same thing as 1 over sine squared of theta. That's the exact same thing. Minus 1. And we're done. We don't need to manipulate this part. This is almost the answer. The hard part is done. You say, well, that's really ugly. What? How long? It really didn't take you very long to get there, right? Okay? This is the part we need to know. And this part deals with the cotangent. Don't think of this. This is what we wanted in our answer, which we have. I want to know what is the value of the cotangent in the second quadrant. Positive or negative. That's all that piece means. So cotangent, in quadrant 2 is what? Positive or negative? Cotangent is x over y. It's negative. X is negative, y is positive. Done. Kind of crazy, right? Remember that we're working up towards something else. You say, I will never ever in my lifetime use this. Don't ever say that. You just don't know. I hope someday you guys come back and say, this is the job I have, I'm totally using all this stuff. Most of you are not going to use this stuff. That's not the key for the rest of you. The key is that you're learning to be confident enough to take a leap of faith to go somewhere and find out if you can search for the answer in the things you've been taught. It's not necessarily that you're using trigonometry to do that. You totally just use algebra to solve this. And you will definitely use those skills in your lifetime. Okay. Ready for another one? Or not? You want to move on? Okay. Secant of theta, this is number 42. The secant of theta, I want that changed to the sine of theta. And it is in the values in quadrant 1. What are all the values in quadrant 1? Okay, so I don't even need to mess with this. Okay, so it's going to be positive. Secant. What do I know about secant and sine? Do the secant and the sine go together over here? No? Do the secant and sine go together over here somewhere?
Kinda, yeah. Cosine, the sine's very tall. Right.
What?
No, my bad. Sorry, that's sine. Sorry.
Okay. We have the secant squared here. And tangent squared is the same as sine squared over cosine squared. There we've got sine squared. And we also have cosine squared. But cosine squared is the same thing as 1 minus the sine squared. Now we're talking 4 and 5 steps ahead. Did I lose you?
Yeah.
Okay. But you did pick out this one. How many of you picked this one out? One person? You're right. What would it do to help you over here? Secant is the same as 1 over cosine. That isn't helping me because cosine doesn't lead me to the sine unless I use this one. And again, now we're 4 and 5 steps ahead. You can get there either way. So the question now is, which way do you want to go? You want to try doing it this way? Or you want to go this way? I'll do it either way.
We do both ways.
I don't remember which way I did my problem, so let's start with this one first.
Yeah, could we do both ways to see how this
We can try.
Alright.
We may get to the point where we're exhausted and be like, okay, forget it. Alright, so 1 plus the tangent squared of theta equals the secant squared of theta. First thing, I want to get secant by itself, right? I want to solve the equation for this, whatever this first one is. So what do I do? Something. How do I get rid of the square?
Square root of sine.
Yeah. Alright, so now, 1 plus the tangent squared of theta. What do you know about tangent
I over x.
in terms of the trig functions? Sine squared over cosine squared. So really we have 1 plus the sine squared theta over cosine squared theta equals. Alright, so now that we have the secant, we can just deal with this part right here. Okay? What do you know about cosine squared?
Where did you cross out secant?
I was just saying we don't need to worry about. This is just an expression.
Okay.
We're not solving anything. An equal sign implies that we're going to solve and get a value or something. I was just kind of throwing it out. Sorry I did that.
Okay.
Secant is equal to this, okay? What is secant equal to? But we want to get rid of the cosine squared. What do you know about cosine squared? What does the cosine squared equal? 1 minus the sine squared. Ta-da! Just because it's ugly doesn't mean it's wrong.
Is that the answer?
Do I have only the sine function used?
Yeah.
Then I'm done. Could I clean it up? Sure, I could get a common denominator, put these two together and see if something else works out of it. I could have gotten cosine squared over cosine squared here, and then I'd have cosine squared plus sine squared, that's 1 over cosine squared, which is totally not what I needed. So sometimes simplifying it before you're done hurts your process. So even though this is ugly, yeah, you can now simplify it from here, but that wasn't the goal. The point was get the secant to be nothing but your sine function, and we did. You wanted to try the other way. Secant is the same thing as 1 over cosine, right? Yay, what do you know about cosine? Cosine is the square root of 1 minus sine squared. I just want cosine, I don't want cosine squared.
Okay.
So it's the square root of 1 minus sine squared. Done. Now is it neat? Is it nice? No, it's not nice. You got a radical in the denominator. And it can get really ugly after that. Okay, so obviously, are these two exactly the same? Not on the surface, they're not. Again, you're just manipulating. Did you get the function to be equal to just a sine? Sure. This one took you longer. Here's what I did on this one. What number is that? 42? I did this one. I did it twice, so I wonder if it did it the same way. Yep, I did the same way. Thinking a couple steps ahead might help, but it doesn't necessarily mean you're going to get the exact same thing each time. Okay? This is really ugly. Now you want to do one of these that really should be easy like this. Let's do another one. Number 44, I want everybody to try on their own. Here, I'll write it up here. And then we'll do some of those other problems that are a little different. Show you how easy they are. Number 44, you're going to try this one. The cosecant of theta. And you're going to change that to cotangent of theta. And the positive or negative, the cosecant is in quadrant 3. So give it a shot. And I'm telling you this, it's easy. You don't need a lot of steps on this one. So think a couple steps ahead. Without even writing anything down, I think most of you could probably tell me the correct answer. I'll give you a second. Think about it. It is really easy. So those of you who don't see it, you're going to kick yourself. I'll give you a hint. It really doesn't help you to use this over here. It's one step. So which one do we use? This one right here? What do I do? Square root. And then you have cosecant is down by itself. Your answer is almost done. It's in terms of cotangent, is it positive or negative? Cosecant is the same thing as secant, or sine, which is y. In the third quadrant, y is negative. So the answer should be negative. That was it. We got it right. Were you doing it this way? Did you use this one?
Yeah.
Okay. That's it. Alright, now let's look at a couple other things that are a little obscure, you're not really used to. If we look at the next section, it says find the values of the trigonometric functions of theta from the information given. So let's do 46, since you can look at the answers in the book of the other ones. Cosine of theta is negative 7/12. It is in quadrant 3. What number is this? 46. What are we doing? You need to find the other 5 trigonometric ratios. You're given cosine. I need the rest of these, the rest of the values. Now watch how this is. This is implying that it's not a unit circle. It's in the third quadrant. So I have a right triangle that's formed. What do we know about cosine? Which is x over r. Which one? That right? That right? X is negative 7. The hypotenuse is 12, so that's why it's negative. Negative over positive, the radius is always positive. Okay, so here's what you have. It is obviously not a unit circle because h is 12, not 1. So how do I find y? Pythagorean Theorem. Good. Negative 7 squared plus y squared equals 12 squared. Everybody tell me what y is, please. And then it becomes very easy after this. Use your calculator. Come on. Or do it in your head, whatever. Oh, I gotta push buttons. The day's almost over. Mr. Locke was so mean. Can't believe he's gonna make us do this. It should be like cheering and allowing you to use your calculator. Leitner, what is it? Anybody at this point. Is that right? 9.7? So y is approximately 9.7. Alright, now watch. The sine is what? What's the sine? Y over, it's not a unit circle, so it's not just y.
The radius.
Y over the radius, y over the hypotenuse. So the sine of theta is 9.7 negative, right? That's important. You don't want to miss it because you dropped a sign. Negative 9.7 over 12. Excellent. So then it ought to be easy to tell me what the cosecant is.
12 over negative 9.
12 over negative 9.7. Excellent. What about, we did cosine, so what's the secant? That should have been the easiest one. 12 over negative 7. See how easy this is at this point? Alright, and the tangent? What's the tangent?
Negative 9.7 over 12. Wait, no. Valid.
Negative over negative is positive, 9.7 over 7.
Yep.
And the cotangent? 7 over 9.7. Okay. Now, we don't normally leave a decimal inside of a fraction, but I wanted to show you, this is how you just set it up. It's very, very simple at this point, right? So what do? You have to take what they have here. You know that this is not from a unit circle. So you have to find the other piece by using the Pythagorean Theorem. That's what you're doing on that. Very simple? Can you do this now? Okay. Let's get the area of a triangle thing out of the way before we run out of time here. You already know the sector of a circle that almost is like a triangle. You know how to find the area of a sector. You know how to find the area of a triangle given that you have the altitude. But you don't know how to find it. You did in Algebra 2, I hope. You don't really know how to find the area of a triangle that's not a right triangle and you don't have the altitude. If you have two of the pieces of the triangle, two of the legs, and you have the degree in between those, you take the sine of that, you can find the area of the triangle. Having said that, number 59, the area of the shaded region. So this is 120 degrees. I want the area of that region. And here you have to use the sector formula and the area of a triangle formula. If I found the area of the whole sector, 1/2 r squared times theta, and subtracted the triangle, I would then have the shaded region, wouldn't I? Okay, 1/2 AB sine of 120 degrees. This one is 1/2. The radius is 2, so that's 4. Theta has to be in radian mode, so you take 120 times pi over 180 minus 1/2. What's A and B in the triangle? What's the two lengths of these? 2 and 2, right? Isn't this the same as that one? So 2 and 2, 2 times 2, times the sine of 120. Calculate that, please. Make sure you're in degree mode, because this is what we're dealing with. You're already transferring this out, so. Yes. Yes. Yeah. Yeah, what is it? I don't remember. I don't have it written down.
2.5.
That sounds about right.
Or 2.
Did everybody else get that? I don't remember what it was. I didn't actually write that down. Do you look is that what it is in the answer book?
Yeah.
Okay, 2.5 square units. Remember, it's area, it's square units. Any questions?